Hi, everyone. My name is Shaira, and I'll be taking this demo session on the topic of quadratic functions. And yeah, let's dive into the topic. So, in this topic, we'll investigate the graphs of the quadratic functions. So, that is where our focus will be on. And the graphs of this quadratic function are nothing but the parabolas. Okay. So here you can look into the real life examples of the parabolas. Say for example, the water fountains, the bridges, and also the telescope. So these are some of the real life examples of parabolas, and we'll try to understand like how to graph the parabolas, how to graph the quadratic functions. So before diving into the topic, I'll give you a quick review on what a quadratic equation is, which you would have already covered in our previous grades, maybe in our lower grades. Quadratic equations are nothing but the expression which has the highest exponent. The expression's highest exponent would be 2, right? So, say for example, the general form of that quadratic equation will be ax square plus bx plus c will be equated to 0. This is what you called it as a quadratic equation, wherein the highest exponent of that expression of that equation will be 2. And this quadratic equation will study the functions on it. So, what is the difference between that equation and this function? Basically, equations will contain only one variable, right? So when you invoke that one variable, so-called the dependent variable, with an independent variable, you call that to be a function. So you have a vast topic about what a function is. I'm not diving deep into it. Rather, we'll just stick on to our topic, quadratic functions. So a quadratic function is nothing but a relation between two variables, so-called a dependent variable and an independent variable. In our case, the dependent variable is the x and the independent variable is the y, which can be written of the form y is equals to ax square plus bx plus c. Simple as that. When you equate that ax square plus bx plus c equals to 0, you call that as a quadratic equation. And when you are equating it with another variable, you call it to be a quadratic function wherein the coefficients of x square x and the constants are nothing but a, b, c, which are the constants. And you have to be clear here where a is a non-zero constant. What happens if a is 0? If our a becomes 0, what happens? The term of the x square vanishes, right? Thus leading it to a linear function. So we don't want to do that. We need to have a specific quadratic function. So we stick of the coefficient of a to be a non-zero constant. Okay. So let us try to consider for any value of x, you will have the corresponding value of y. This can be found using the concept of substitution. We'll look into a problem based on it. So determine whether the given point satisfies the quadratic equation, quadratic function. Meaning the point given is a coordinate, right? Coordinate point, meaning x comma y. So if I substitute the value of the dependent variable into the function we have, we will get the corresponding values of y for that. Okay, we'll try using it. And if it is so, like if I substitute my value of x to be 2 and if we get the value of y to be 16, that it means this point actually satisfies the quadratic function, meaning that point will lie on the graph of the quadratic function, will be there in the parabola. Okay. So if I'm putting x to be 2, what does that mean? X is 2, then y will be, it's mere substitution. So 3 times 2 the whole square plus 2 times x. In place of x, I'm just putting 2. So that would be 3 times 4 plus 4. So that would be 12 plus 4, which is 16. So the value of y is nothing but 16. So when I put value of x to be 2, we get the value of y to be 16. So this problem you can try it on your own. The same as that. You have to check whether that point satisfies the equation or not. So from this problem, we can also understand given a value of x, you will be able to find the value of y. That is nothing but the plotting points we will be able to find from this type of questions. Okay, given a function, you will be able to find different types of plotting. So basically, we'll stick to the easiest form of quadratic function, so called y is equals to x square. The general, when you put it into the general format, it will be y is equal to 1 into x square plus 0 times x plus 0, where your b and c will be 0 in this case, and our coefficient of x square is nothing but 1. Okay. So the simplest quadratic function is y is equals to x square. So how will you annotate this quadratic function? Like how will you graph the function? As I told you earlier, by mere substituting the values of x, some values of x, like any random values of x you can choose. Mostly, I suggest you to choose specific integers on the number line, okay, on the coordinate axis. So, let us choose the coordinates of negative 3 to positive 3 for the values of x's, and we'll try to find the values of respective y's. Okay. So if we put the values of x to be negative 3 here, what happens? When y is equals to negative 3 the whole square, it becomes what? Positive 9, right? So y is 9. So similarly, let me fill the other values of respective y's for the x's. So that should be 4, this is 1, 0, 1, 4, and again 9. So upon so what do we actually get from this tabular values? We get a sequence of plotting points, right? So I get my plotting point to be negative 3 comma 9 and negative 4, 2 comma 4, 1 negative 1 comma 1, 0 comma 1, 1 comma 1, 2 comma 4 and 3 comma 9. So I get such plotting points. So we'll see like how to plot it on the graph. So basically we'll have a graph of this type, correct? And I'm just randomly marking the points. I should have done it earlier. So this is like positive wise, and this is negative wise, and this is positive x's, and this should be our negative x's. Okay, so it's negative 3 comma 9, meaning x comma 1, correct? So negative 3 and 9 will be somewhere here. Like approximately I'm doing it. So negative 3, 2 comma 4 somewhere here. Okay, and negative 1 comma 1 somewhere here, exactly here, and 0 comma 1 on x-axis, 2 comma 4 over here, and 3 comma 9 again over here. So approximately our graph will be something like this, connecting all the points approximately. Okay, and like this is not the scale curve. Okay, 0 comma 0. Okay, fine. Comma 0. Yeah. So this will be the graph of y is equals to x square. This is how the exact graph of y is equals to x square will be. So what is this called? This is nothing but the real life examples that we have seen earlier. No? It's nothing but the parabolas. So the graph of a quadratic equation are nothing but the parabola. Quadratic function is called a parabola. Okay. And you can see to it where the turning point occurs. Correct? So the turning point occurs at 0, comma 0. So this is called the vertex. Okay. So wherever the turning point is, you call that to be the vertex. And um, if the graph is open upward, you have open up graph and open down graph, open down parabolas, open left and open right parabolas also. Like in your specific syllabus, we'll concentrate on the open up and open down parabolas. Okay. So for open up parabolas, your coefficient of A will be strictly positive. Open down parabolas, coefficient of A will be strictly negative. So from that itself, you can identify whether it's open up or open. So for open up parabolas, what happens? You have the vertex here, right? This is will be the turning. So you call this as the minimum turning point or the minimum point. Okay. And this will be concave upward. And if it's down, up and down, then you should have a max turning point, and it will be concave downward. Okay. And then there will be a line of symmetry, or you call it as an axis of symmetry, where the vertical line that passes through the vertex of the parabola. Okay, so every parabola will be symmetrical about its axis of symmetry. And the parabola that passes through the x-axis is called, those points are called the x-intercepts. And the value of y, where the graph crosses the y-axis, is called the y-intercept. In this case, what is the x and y-intercept? So x-intercept is nothing but 0, comma 0, right? Because it touches the x-axis at 0 only. So x is 0 there. And for y-intercept, y-intercept point is also at 0. So x-intercept and y-intercept is nothing but 0, comma 0, which is the vertex in this case. So basically, those x-intercepts are there, no? They are nothing but the roots of the quadratic equation. So you can visualize it like very clearly in this graph. That graph was at the vertex, we had it at the origin, but you can also have a graph where the vertex is at a different place. You will learn like how the transformation and all happens in the transformations of the graph. Okay. So now we'll stick to the topic, and this will is nothing but the vertex. As I said, you the minimum turning point called the vertex, and the axis of symmetry passes through the vertex, and you will have an x-intercept where the graph crosses the x-axis. So you have two roots for this quadratic function. Based on by interpreting the graph itself, you will be able to say all these things. Okay, that is why I'm mentioning it here. And you have the y-intercept also, the y values, and you call this as a parabola. I hope this is clear now. Okay, so for time constraint, what I'll do is we have like three types of quadratic form. Let me explain you one alone. The rest you can take a look at it later. Okay, so this quadratic form exists in three types. Okay, like three types is so far mentioned according to your syllabus. You will have like many types, but even those many times exist, you will be able to categorize or decode it into these three types of the quadratic form. Okay. So first one is you will be able to express this y is equals to ax square plus bx plus c by factorizing this quadratic equation into this format, a into x minus p into x minus q. Okay, where p and q are nothing but real numbers, and you have to make sure your a is non-zero, because that's a very important condition for a quadratic function. And how the graph will be is you will have the vertex at a point where this P and Q becomes the x-intercepts. Okay. And that vertex will have the x coordinate as P plus Q by 2. That is the mean of it. Okay. And the axis of symmetry will obviously pass through that, right? So axis of symmetry is the line passing through x is equal to P plus Q by 2. Okay. We'll try to do a problem on this type. So here you can see to it, as I have already mentioned, check for your A. Our A is when you try to relate the given form and the given question, you come to know that your A is 2, your P is, see to it, it's x minus P. So obviously this should be negative 3. P value is negative 3. Okay. And Q will be 1 only because x minus Q, and here also you have it in the form of x minus 1 only. So you can see that the ray is 2, meaning it's strictly positive. So you will have a open up parabola. Then we'll see how to solve this, like how to graph it. We need to sketch the graph using axis intercepts, and we need to state the equation of the axis of symmetry. We have to find the intercept values and the axis of symmetry. Okay. So how can we do it? First and foremost, stick to it by finding the intercepts. How can you find the intercepts? We have seen earlier, no, by the method of substitution. Intercepts are nothing but the values of x and y, correct? That is the graph which passes through the x-axis and also which passes through the point on the y-axis. Those are the intercepts. So when you put some specific values of x, you get the value of y, and you vice versa happens for y too. So for intercept, when x is equals to 0, okay, you will get the value of y. That is the y-intercept value you will get. So on y-axis, x is 0, right? So when you put x as 0, what happens to y? Mere substitution. So it will become 2 into 0 plus 3, which is 3, 0 minus 1, which is negative 1. So it is negative 6. So you get a plotting point as 0, comma negative 6. Okay. And then we'll try to substitute y as 0. If I put y as 0, what happens? It's 2 into x plus 3 into x minus 1 is equal to 0. Correct? Meaning our 2 will become 0 and we have x plus 3 into x minus 1 as 0. So we already know about when there exist two product of the numbers equated to 0, either a will be equal to 0 or b will be equal to 0. The same thing you would have done in your factorizations also. So the values of x will be what? Negative 3 and values of x is 1. Done. So you can either find the x-intercepts by these things or by the fact that's already given. We know, right? P and Q are the x-intercepts. So by that also you can find. If you don't remember that, follow this method. Okay. So it's negative 3 and 1 are the x-intercepts. So we'll try to plot it. So our graph is this is negative 1, negative 2, and negative 3, and this will be 1, 2, and 3. This is yeah. So first we'll mark the x-intercepts, which are nothing but negative 3 and 1. So negative 3 comma 0 obviously and 1 comma 0. So these two are the points. So we got like the parabola is open up and it passes through and it passes like this. Okay. Now what we need to find? We have to find the vertex. What is the vertex coordinate? It's p plus q by 2. So it is negative 3 plus 1 by 2, which is nothing but the vertex is negative 2 by 2, which is negative 1. Correct? So the value of the vertex is x is equals to negative 1. So where is x is negative 1? X will be negative 1 in this case. Correct? So this is the line where the axis of symmetry passes through. Correct? So that is nothing but the x coordinate of the vertex. See, axis of symmetry is the line equation. We can draw it at the point. We can draw the equation x equal to negative 1. Linear equation we can draw. But what about the vertex? So x value we got. Simple. Substitute in the equation and find the value of y. So y will be what? It should be, okay, I'll put it here. Y will be 2 times x is negative 1, right? So negative 1 plus 3 will be 2 and negative 1 minus 1 will be negative 2. So what is the value of y you get? You get it to be negative 8. So the vertex point is negative 1 comma negative 8. Hope that is clear. So what do you get? It's negative 1 comma negative 8 somewhere around here. Correct? Somewhere around here. And see to it, you also have the intercept of y, which is negative 6. Let me mark it over here. Okay, this point also we have. So now we'll try to draw the graph. So it starts like this and goes around the vertex, takes a turn at the y-intercept and go touches the x-intercept again. What you do? You just extend the graph. Extend the graph on both the sides. Okay, since I'm using my pen tab, this is not appropriate, but you have to use a pencil to draw it exactly on your grid sheet. Okay, so this is how we find the graph of the quadratic function when the function is of this. Hope it's clear. So we have two other forms of the function also, a into x minus h the whole square and a into x minus h the whole square plus 1. So I have provided the specific facts and also the graph for them. We have to do the similar method here. And this is the final result. I told you earlier about these two things, right? And if our A is between negative 1 to 1, you need to see to it the graph is wider than the preference graph of y is equals to x square. And if it is lesser than negative 1 or greater than 1, it will be narrower than the preference graph of y is equals to x square. So these are the reasons that are important. Yeah. that's it. So in today's demo session, we have seen about like what a quadratic equation is and what a quadratic function is, the relation between them, and how the graph of the quadratic function would be. And we have seen the various types that quadratic function can take and its respective graphs and the facts of it. So that's all for today's session, and hope you understood it. Thank you so much for this, and bye.